So first find out the cross product like this, and you already know Zi, so you can construct a column matrix. 6 rows, 1 column. Okay, so what we'll do is we'll first define the cross product. So I'm just going to call it cross as this. So this will be cross of Zi minus 1 will be Zi. So this will be Z of times, so comma, right, comma, will have difference of 2 vectors. So this will be, what is ON? How can I write ON?
Robot dot n.
Exactly, O of the last column, so O of comma. Actually, if we had n, that will be perfect. So what I'm going to do is I'm going to go here, just so that we can use n. I'm going to say n is equals to here, robot dot n, okay? And then we can use n as the number of degrees of freedom everywhere. Or you can also write robot dot n here, it does not matter. Just to make it a little more clear, I'll put it like this. That is the ON matrix, minus O of okay, and then we can construct the temp matrix, the temporary matrix like this. This will be equal to so now you can have this as a J matrix here. So when I run this, I should have here. This is a column matrix, 6 columns, each for Alright, so let's say that I have a joint velocity and I want to know what the end effector velocity is. So let's take an example where I have a certain joint velocity, I want to convert it to an end effector velocity. Joint velocity is q dot, so I'll just say qd is, let's say my joints are moving at this rate, 0.01 radians per second or 0.01. Then my prismatic joint is moving at the rate of 0.1 meters per second. Okay, and this is in the negative direction, 0.2. And then let's say I have 0.2 radians for the wrist. Okay, and minus 0.3 radians. And let's say for the final one, this is, okay, I'll say this is my, I'm going to say, mention this as joint velocity. Okay, these are my joint velocities. If I want to know my end effector velocities, here, I can find eta as J, which is the Jacobian that you have found, times QD. Okay, let's write this as QD, which will be equal to end effector velocities. Okay, so you can convert joint velocities into end effector velocities like that. Okay, so here's what I want you to do as a assignment for this coding project. You'll convert this into a function as follows. Okay, you'll convert this program. I want you to write a function that will generate the Jacobian independent of the, in this case we used a known structure, but in a general structure what you will have to give is this. So we'll say, we'll call this as Jacobian velocity. This is the name of the function. The input to the function will be the robot object, okay, and QD. Actually, let me, Q, comma, QD. Okay, this is your, let me explain, this is your robot object. This is your joint displacement or posture. Okay, posture matrix. This is your joint velocity. What I want from this is the following. I need the function to return two values. The first one it should return is the Jacobian matrix, and it should return the end effector velocity eta. Okay, it should give me what is the Jacobian matrix, J of Q, and this should give me the end effector velocity. Alright, so it is independent of number of degrees. The robot will have dot n. You can find out whether it's 3 degrees, 4 degrees, 5 degrees. You can automatically know from there. For each of the links you can look up sigma and find out whether each of them is revolute or prismatic. Okay.
even more.